we want to be able to work out the area of a sector. Now we know how to work out the area of a whole circle. The formula for that is just pi r squared, pi times the radius all squared. So if I want the area just of the sector, so just of this sector here, then obviously this is a fraction of the whole circle. And as we saw in the previous topic, if this angle here, we'll call it theta, then the fraction of the circle that we have here is theta out of 360. So this is your formula for working out the area of a sector. So in this example, I want to be able to work out the area of this sector here. So I'm going to use the formula that we've just seen. So I'm going to do pi times by the radius, which in this case is 4 squared, multiplied by the angle, which is 110, divided by 360. And if we type that into our calculator, we can see that to 3 significant figures, we get our answer as being 15.4 centimetres squared. So that's a pretty simple thing to do. We also need to be able to work out the area of a segment. Now a segment looks like this. I want to be able to work out the area just of this shaded region here. So in order to do that, the method I'm going to use is I'm going to work out the area of the whole sector, and then I'm going to take away the area of the triangle. Hopefully you can see that if I worked out the area of this whole sector here, and then took this triangle away, took that triangle away from this, then that would give me the sector. The segment here. So, to work out the area of the sector, we've just seen the formula for that is pi r squared times theta over 360. So this is the formula for the area of a sector. The formula for the area of a triangle, hopefully you remember this from trigonometry, is a half AB sine C, where the angle C has to be the angle that's in between these two sides. So, the radius here is 5, so we've got pi times 5 squared times 40 divided by 360. So that's just making the radius 5 and the angle 40. Over here, I know that if this is 5, then I know that that's 5 as well, because these are both the radiuses of the circle, or the radii of the circle. So I've got a half times 5 times sine of 40, and this would give me the area of the triangle. So if I substituted both of those into the calculator, I'd get those answers, and taking those away, that gives me the area of the segment.